Good morning, good afternoon, and good evening. This is Michael Herman, and today we're talking about the Web 7.0 Trust Spanning Layer Framework. This is a follow-on to the previous tutorial, the previous Web 7.0 tutorial that created the Web 7.0 DIDCOMM HTTP profile for the TOIP Trust Spanning Layer framework, and this actually brings the Trust Spanning Layer framework home to the Web 7.0 project itself. It features two credential receiver models, the raw credential receiver, sender receiver model, and the verifiable credential receiver model. So the agenda, after a quick introduction, we'll talk about what the Web 7.0 version of the Trust Spanning Layer framework looks like. Of course, it needs to have an acronym, TSLF. As a bridge from the previous presentation on the DIDCOMM HTTP profile for the TOIP framework, we'll revisit the DIDCOMM Layer 3 mapping. Then we'll talk about raw credentials and provide a specific definition of what raw credentials are, and talk about the raw credential sender receiver model. And that happens to be a layer 2, so it's part of the trust spanning layer. From there, we'll derive a definition of verifiable credentials and the verifiable credential sender receiver model. Because this is a derived model, because it's based on the raw credential model, it actually lives in layer 3, the trust tasks layer of the trust spanning layer framework. As a result of this derivation of the verifiable credential sender receiver model from the raw credential sender receiver model, it was a natural step, a natural evolution to revisit the issuer holder verifier model, and it in fact is a natural extension of the verifiable credential sender receiver model. So what we end up with is a hierarchical taxonomy, the beginnings of a hierarchical taxonomy of credential sender receiver models, and so that's pretty cool. And then we'll finish up with some. So all of this originates with the DIDCOMM agent architecture reference model, a design guide for software architects and developers building decentralized systems, decentralized software and hardware systems. Again, the three goals of the white paper and hence of the project are to better understand the active components of a DIDCOMM or decentralized agent-based software system and how they rely and interact with each other. Introduce, in this case, we'll be using a new graphical modeling language called DIDCOMM notation that helps aid architects and developers in visualizing new architectures and designs for these decentralized software systems. And we'll describe, or in this case, leverage the layered architecture reference model known as the DIDCOMM-ARM or DIDCOMM architecture reference model. And this will help guide the design and creation. This architecture reference model will help guide and design the creation of the broadest range of DIDCOMM agent or decentralized software systems. When we talk about Web 7.0 and the trust spanning layer framework, there's 4 standard layers, and these correspond to the TOIP layers. So layer 1 at the bottom there is the trust foundation layer. Layer 2 is the trust spanning layer. Layer 3 is the trust task layer, and layer 4 is the trust agent model or application or app layer. In this particular presentation, we're going to drill down a little bit more into the layer 2 trust spanning layer and the layer 3 trust task layer to talk about credential sender receiver models. We're going to start with layer 2 and the raw credential sender receiver model. Provide a definition for raw credentials and illustrate what the raw credential sender receiver model is all about. And then from that we'll drive the definition for verifiable credentials and the verifiable credential sender receiver model, and then show through successive layers of specialization or through successive layers of derivation how we can evolve or create the issuer holder verifier model, and for completeness show the derivation of two other models, an issue purchase order model and an issue vaccination credential model. So here's what the Web 7.0 trust spanning layer framework looks like. There's the 4 layers on the left, starting at the bottom, the trust foundation layer, followed by the trust spanning layer, followed by the trust task layer, followed by the trust agent layer. And the items on the right, the DIDCOMM HTTP profile, are the same ones that we discussed earlier when we mapped the DIDCOMM-ARM architecture reference model to the TOIP hourglass model. And we're not going to drill down into each of these. We'll kind of talk about all of them in turn. And then we see graphics from the DIDCOMM notation on the right hand side. At the bottom, the DID registry, which is really one of the key components of layer 1. And then above that we see a credential, just a raw credential, a credential that's unsigned, potentially unsigned, not necessarily verifiable. And then above that is the DIDCOMM notation symbol for a verifiable credential, and above that, top right corner, is a DIDCOMM agent. So let's look at layer 3 just as a reminder of where we left off last time. Layer 3 in the DIDCOMM-ARM. So this is about being able, ABC Grocery being able to send a purchase order for 10 cabbages over to David's Cabbages, which is a farm business. And so at the bottom there you see the purple line which represents the auth encrypted DIDCOMM message that is originating from the ABC Grocery DIDCOMM client, the fellow on the right, and that's being sent across to David's Cabbages software agent or DIDCOMM agent, the order endpoint where these purchase orders need to arrive. And in the middle at the bottom we see the DIDCOMM message attachment that's being sent. In this case it's a purchase order verifiable credential. And of course that communication is achieved by looking up David's Cabbages DID, the DID::org:111222333 in the DID registry, retrieving the DID document. The ABC Grocery agent then extracts the service endpoint for David's Cabbages and sends that DIDCOMM message with the verifiable credential attachment over to David to deliver that purchase order. If we remind ourselves how that maps onto the Web 7.0 trust spanning layer framework, the bold items in layer 2 and layer 3 are the ones that are directly involved with this. Anything that is in black are the supporting layers in layer 0, layer 1, and layer 2 of the DIDCOMM-ARM. And then the gray ones represent higher level functionality that isn't part of the DIDCOMM-ARM layer 3. So if we start looking in layer 2, we can see that to realize the transfer of this verifiable credential purchase order from ABC Grocery over to David's Cabbages, we're using DIDCOMM attachments, and we're also making use of the raw credential sender receiver model. More specifically, if we look in layer 3, we're actually using the verifiable credential sender receiver model, which is a derivation or a specialization of the raw credential model. And we're going to go into a lot of detail in the next few slides to explain where we're starting off with the raw credential model, and then subsequently the verifiable credential model. So raw credentials and the raw credential sender receiver model. Again, this is part of layer 2 of the Web 7.0 trust spanning layer framework, the trust spanning layer. So the definition we use in Web 7.0 for a credential definition, raw credential definition, and we try not to use the word credential by itself, just like we try not to use the word SSI by itself, just like we try not to use the word DIDCOMM by itself, because each of those words as unconscious contractions have so many meanings. So we're trying to center our conversations around raw credentials and not just plain old credentials. So in Web 7.0, the following terms and concepts are equivalent. They're one-for-one equivalent or synonymous. Raw credential, a collection of properties where one of the properties is an identifier. A collection of attributes where one of the attributes is an identifier. A collection of name-value pairs where one of the pairs is an identifier. A collection of claims where one of the claims is an identifier. Collection of assertions where one of the assertions is an identifier. So the idea is whatever lingo you want to use, it's pretty obvious to see the pattern here in terms of what's a credential. There's an important footnote there at the bottom. A raw credential by definition is not a verifiable entity, unless of course the credential has a verifiable proof associated with it. So raw credentials may or may not have a proof, and they're raw credentials because they meet one of these definitions here in the bullets. So let's look at what the raw credential sender receiver model looks like, and then we'll talk about verifiable credentials. So here is the raw credential sender receiver model. So on the right hand side we have a DIDCOMM agent. And that DIDCOMM agent is sending a message with a credential attachment over to the receiver on the left. What are the steps on the right that the raw credential sender goes through? They create the credential, they auto-encrypt the message and that credential attachment, and then they send the message. They send the auth encrypted message over to the receiver. What does the receiver do on his or her end? They receive the message. They decrypt it, they verify the sender, they detach the credential, and then they process the message and the credential through whatever workflow or business process is appropriate, usually dependent on the type of credential that's received. So this is for credentials that might be verifiable and might not. This is the generic raw credential sender receiver model. And because it's so basic and common to all DIDCOMM communications, it belongs in layer 2, the trust spanning layer. And so we see it highlighted in bold. So let's contrast what we've just learned about raw credentials with verifiable credentials and the verifiable credential sender. So a verifiable credential is a credential, a raw credential, a credential that has a verifiable proof associated with it, plus some additional metadata. When this credential has that verifiable proof associated, the credential is referred to as a verifiable credential. All verifiable credentials are raw credentials, and only raw credentials with an associated verifiable proof are verifiable credentials. So the second bullet, everything's a raw credential. Not everything is a verifiable credential. It has to have the verifiable proof associated with it. So to have this verifiable proof associated with the credential, we need a few extra steps. So this is the verifiable credential sender receiver model. So on the sending side, we create the credential, we sign it. Then we auth encrypt the message and the verifiable credential attachment, and we send the message. So this is what we call outbound processing, the purple box on the right-hand side with the outbound interface. On the left, when we receive that auth encrypted message with the verifiable credential attachment, we have, again, a couple extra steps. We receive the message like before, we decrypt it like before, we verify the sender before. We detach the verifiable credential like before, and then number 9, we verify the verifiable credential. Because we know it has a proof now, and so we can, I guess optionally, but almost always, we'll be verifying the validity and authenticity of that verifiable credential. And then finally, step 4, we're going to process the message and the verifiable credential received. So on that receiving side, really the only extra step is step 9. Because we have a proof associated with the credential, we need to verify it. More often than not, we'll need and want to verify it. Going back to the sender side, the only extra step is step 2, and it's really the counterpart of step 9, where we're signing that credential before we attach it to the message and auth encrypt it. So how does this fit into the layer framework for Web 7.0? So we can see that it's a trust task. It's a higher level function. It's a higher level function built on top of the raw credential sender receiver model. So with those is kind of the basic premise, the basic idea. Let's look at the issuer holder verifier model. So this is the classic issuer holder verifier type of diagram. This one's from Wikipedia. And the issuer on the left issues a credential and acts as a sender. It is received by the holder, so the holder is acting as a credential receiver. And then that holder may want to present the credential itself or present a verifiable presentation. In this case, on the right-hand side of this diagram, the holder is acting as a credential sender, and the verifier is acting as a credential receiver. So to illustrate that, I've got a credential sender in the left. The issuer is a specialization of a credential sender, and the holder in this case is a specialization of the credential receiver. Moving over to the right-hand side, the holder is also a specialization of the credential sender. When Alice, in this case, is sending the verifiable credential or verifiable presentation to the bottom right to the verifier. The verifier is a specialization of a credential receiver. If we were to go back and look at the detailed tasks of a verifiable credential sender and a verifiable credential receiver, you'd see that they're providing the functions and capabilities to realize the issuer-holder verifier model, and that the issuer-holder verifier model is really just a specialization of the verifiable credential sender receiver model. So you can imagine already what layer that belongs. It belongs in layer 3. The issuer-holder verifier model there in bold is a derivation, is a specialization of the verifiable credential sender receiver model. When the verifiable credential sender receiver model, in turn, is a specialization or a derivation of the raw credential receiver model in layer 2 of the trust spanning layer framework. So we've got these 3 steps. We're beginning to see that we're on the cusp, if you will, of creating a hierarchical taxonomy of credential sender-receiver models. So let's illustrate that hierarchy here. So let's go in reverse order. Let's start at the top. So we've got the issuer holder verifier model that we've already seen and what we've looked at. And we can believe that on the left, where the issuer is acting as a specialization of a credential sender, sending it to the holder, who on the right or left-hand side of this diagram is acting as a credential receiver, is really just an instance of the verifiable credential sender receiver model in the middle of this diagram. On the right-hand side of the issuer holder verifier model at the top, the holder is acting as a credential sender, and the verifier is acting as a specialization or derivation of the credential receiver. Another instance of the verifiable credential sender receiver model in the center. So if we use that blue arrow to mean is a specialization of or is derived from, and this is a formal concept, specialization, taken from the Archimate Enterprise Architecture framework. Let's go one level down. Let's look at the verifiable credential sender receiver model itself and how it's derived from the raw credential receiver model at the bottom. So we're not going to go through the definitions of raw credentials and verifiable credentials again, but if you were to look at the steps of the verifiable credential sender, they map one-to-one with the raw credential sender. The only addition in the verifiable credential sender receiver model is step 2, where we're signing the credential before we're attaching it and before we're doing the author encryption of the message with the attachment. On the left-hand side, the verifiable credential receiver is identical one-to-one with the raw credential receiver. The only difference there is step 9, where we're verifying the credential sender. So verifiable credential sender receiver model is a specialization again, or a derivation of the raw sender receiver model, the purple arrow. In turn, the issuer holder verifier model at the top of the page is a specialization or derivation from the verifiable credential sender receiver model in the middle of the blue arrow. Highlighted there. Let's look at a couple of other examples for completeness. Let's take the issue purchase order scenario from the earlier versions of the DIDCOMM-ARM tutorial. It's covered both primarily in part 1, but also in part 2 of the tutorial. As we've mentioned before, ABC Grocery is an organization, and they're trying to order 10 cabbages by sending a purchase order using DIDCOMM, a purchase order verifiable credential, or a purchase order encoded as a verifiable credential over to David Cabbage's software agent, the order endpoint for that software agent. We see that illustrated. We see that illustrated here. Let's look at issuing a vaccination credential, and again, this is a layer 3 example. On the right, we have the vaccination authority, the health care system, or the HMO, or the government, or whoever it might be. They're represented by the institution or the organization on the right, and they're sending a DIDCOMM credential, of the vaccination verifiable credential, the vaccination encoded as a verifiable credential, to the software agent, to Alice in this case, who's acting as a holder. And almost one-to-one with the previous example of issuing a purchase order, we've just changed the nature of the verifiable credential and the nature of the two parties that are involved. So let's go back to hierarchical taxonomy of credential sender receivers. The issue purchase order model is really quite synonymous with sending a verifiable credential. It's a specialization again, so that's what the blue arrow represents. It's a specialization of the verifiable credential sender receiver model in the same way that the issuer holder verifier model in the center is, well, a twice over specialization of the verifiable credential sender receiver model. Similarly, our issue vaccination credential model is a specialization, again, of the verifiable credential model. We're just changing the credential that's being exchanged and the nature of the two parties there. So here's kind of the beginning to see the full realization of this hierarchical taxonomy of credential receiver models. And then just highlighting, there's the red line there. Below the red line is the layer 2, trust spanning layer of the Web 7.0 trust spanning layer framework. Above the red line, kind of hidden by the blue box now, is the layer 3 trust tasks layer. And so it's the natural home for the verifiable credential sender receiver model plus any derivations, such as the 3 that we've seen here. I guess to visually emphasize that, we can see these 3 sender receiver models, the issuer holder verifier model, the issue purchase order model, and the issue vaccination credential model are all derivations of the verifiable credential sender receiver model at the top of the list, and the verifiable credential sender receiver model in turn is a derivation or specialization of the raw credentials or sender receiver model in layer 2. So that was a little bit quick. You might want to look at it a couple times. If you have any questions, Freddie the Architect is available on Twitter to answer any of your questions. Just tweet your questions or send a direct message to @FreddieArchitect. And thank you for watching. Look forward to hearing and reading your questions, and we'll be providing prompt answers for you. Thank you.